take a moment to pause the video and read over the problem. After reading the problem, we recognize that the volume of a right circular cone is described by the formula V equals 1 over 3 pi r squared h. We know that h represents height of the tank, d represents the depth of the water, capital R represents the radius of the tank's base, and r represents the radius of the water's surface. We know that h equals 100, d equals 40, r equals 25, dv over dt equals negative 2. It is negative because volume is decreasing as the water leaks out of the tank. Here is a picture that clearly illustrates what the variables are supposed to represent. So, we are asked to find dd over dt. No information is given about dr over dt, so we know that r must be eliminated from the problem. And looking at the triangle, we see that the isosceles triangles are similar. So what we do is that we set up a proportion relating the heights and the radii of the tank and the water it holds. We solve it for r. Next, we substitute the value of r, which is d over 4, and we put it into the volume formula to eliminate it from the equation. Next, we differentiate with respect to t, then substitute the known values into the formula and solve for dd over dt. Notice that in the first two steps, we ignore pi over 48 because it is just a coefficient. We multiply pi over 48 when we are done taking the derivative. When we solve for dd over dt, we get negative 1 over 50 pi. We plug it into our calculator in order to get a decimal. Once we plug it into our calculator, we find the depth of the water in the tank is decreasing at a rate of about 0.0064 feet per day. Now that we found the answer for that problem, try this similar problem on your own. And just for reference, this is the water tank we are talking about in the equations.